Hello students, in this video we are going to see the topic transactions in database management system. First of all, let us see what is the definition of transaction. So transaction basically is a unit of program execution that access and possibly updates various data items. A transaction is a result of execution of program written in DML or programming language. So here the transaction is any unit of program, or it is rather a block of code which executes, and this program access the data item, and generally the transaction changes that data item. This transaction can be written in data manipulation language or in programming language. In programming language, the transaction can be written in the code between begin and end statement. So whenever there is a begin transaction and end transaction, in between these two transactions, whatever code is written, that is the transaction that user want to perform. In daily life, there are many types of transaction. There are financial transaction we do. We transfer the money from our account to another account, or somebody transfers the amount to our account. We generally do online shopping. So whenever we do online shopping or transfer money from one account to another account, these are all the examples of transaction. Now, for successful transaction, each and every transaction has to follow some properties. So there are 4 properties which are called as ACID properties, where A is atomicity, C is consistency, I is isolation, and D is durability. This is the diagram which shows the states of the transaction. So whenever there is a transaction, in that transaction, it is in one of the 5 conditions or one of the 5 states. Initially, the transaction is in active state. After active state, it will go into either partially committed state or it may go into failed state. If the active transition enters into partially committed state, either it is committed, that means it is successfully transferred or it is successfully generated or completed, or the partially committed transaction may get fail due to some reason. But if the active transaction is failed at very early stage, it gets aborted. But in case of partially committed transaction, you have 2 choices. Either that transaction get committed, that is the transaction is successful, or it is failed. And if the transaction is failed anyhow, it will go into aborted state. Now let us see what are the meanings of these 4 properties, that is ACID properties. Atomicity. In atomicity, the transaction check whether all the operations of the transactions are reflected properly in the database or none. That means the transaction either should be fully complete or successful, or the transaction never takes place. So that is atomicity. Consistency. Execution of data in isolation preserves the consistency of the database. If the database is modified, all the values in the database should be consistent. Now let us see what is the isolation. Even though multiple transactions may execute concurrently, system guarantees that for every pair of TI-TJ, it appears to TI either TJ finished execution before TI started, or TJ started execution after TI finished. So at a time, only one transaction get executed, and when it executed, the transaction has to check whether the first transaction has been completed or executed, then only it starts its execution. Now durability is the last property in asset property. After a transaction completes successfully, it has made to database persist even if there are system failure. So that is durability. So when transaction is completed successfully and if this transaction changes the values in the database, that values should persist in the database after system failure also. So that is durability. That means whatever changes you do in the database, those changes should be durable. Now, whenever the database is accessed, the database access is accomplished by readx and writex function. Readx transfer the data item x from the database to local buffer and writex transfer the data item from local buffer of the transaction and that executed the write back to the database. So that is the write operation. Now we will see some properties of transaction by looking at one example. So let Ti be a transaction that transfer $50 from account A to account B. This transaction Ti transaction is defined as read A. Here account A value is read. For example, in account A we have $300. Now as we are transferring the amount of $50 from account A to B, we have to subtract that amount from account A. So A is equal to A minus 50. So we have to subtract 300 minus 50. Write A. Now whatever value is changed, that has to be updated in the database. So write operation is performed in account A. That means initially we have 300 rupees in A account. Then 50 rupees are transferred from account A to B. That means now we have $250 in account A. After that, read B. For example, in B account we have $400. Then we are going to transfer $50 from A account to B account. So B will be added with $50. So B is equal to B plus 50. That means 400 plus 50. And again, the updated value of account B has to be saved in the database. So write operation on B account has to be performed. So write B, that means after $50 are transferred from account A to B, we have 450 rupees in account B. Now let us see what is the consistency. The consistency requirement here is that the sum of account A and B be unchanged. So that is the consistency. If we are transferring money from account A to account B, then the addition after transaction and before transaction of both the accounts should be same. For example, before the transaction we have 700 rupees in both the account A and B. And after transaction also we have 250 plus 450, that is again 700. So that is the consistency. By execution of transaction, ensuring consistency for an individual transaction is the responsibility of the application programmer. So whatever code is written in begin transaction and end transaction, that has to be correctly written by the application programmer. Now what is atomicity? Suppose value A and B are $1,000 and $2,000 respectively. So consider here in account A we have $1,000 and account B we have $2,000. Suppose TI is not possible due to failure. So many failures are there. There may be system failure, there may be power failure. So due to that failure, assume that TI cannot be possible. So if failure occurs after write A operation executed, but before execution of write B, then A has $950 because write A operation is successful. But B has only $2,000 because write B is not successful due to failure. But expected value of account B is $2,050 because we are transferring $50 from account A to account B. But due to system failure, the $50 has been deducted from account A, but it will not add it to account B. Hence, there is a loss of $50, sorry. So this is atomicity. So this type of problems may occur in the transaction. So atomicity says that either the transaction should be fully completed or it should never happen. So to ensure atomicity, database system keep track of old values of any data on which transaction performs a write, and if transaction does not complete its execution, the old values are restored to make it appear that transaction never executed. So this